that the volume of a gas
Has a lot of torque.
and the temperature of a gas is directly related. And so you get this kind of relationship. V over T equals a K. Okay?
Wait, you said forget all this.
I said forget all the cross, multiply, and divide stuff.
Remember.
Okay. All right, this is not going to be cross, multiply, and divide.
I know, but you said to like
Okay.
throw it all out. That's
So
right.
just like Boyle's law, if we have an initial temperature
Right.
and an initial volume and temperature, and that's going to equal K, and if we change either one of those values, the other value has to change, so that V2 over T2 is still equal to K. Well, that gives us our most practical form of this equation. V1 over T1 equals V2 over
I found that
T2.
equation too, Mr. Tedder.
Good for you. It's right there. So everybody put their finger on
Put your
their
finger on it,
test
guys.
references where we have this gas law listed. Okay? Well, this is a direct relationship. And a direct relationship, if you remember from Unit 1,
It goes down.
You know.
no, sir,
Nope. It goes.
that's a direct relationship.
That's like a 90-degree angle. with-
Anytime volume goes up, temperature goes up correspondingly.
Okay.
Okay?
Right.
Now, it's also true that because this is a direct relationship, that T1 over V1 equals T2 over V2. Okay?
Oh, you can use
You can use that.
that.
Yeah, Tom would
You know
know.
which one to do.
Well, that therein is the secret of this whole thing.
Tom.
You cannot solve for a variable. You cannot directly solve for a variable that's on the bottom of a fraction. This is really, really important because a lot of students make this mistake. They try to solve for a variable that's on the bottom of a fraction. The answer you get is not going to be that if you solve for that while it's on the bottom of a fraction, the answer you get is going to be the inverse of the correct answer, and it's not right.
Yeah.
Okay? So when you solve for your answer, whatever it is, you've got to have your unknown on the top of the fraction. Does that make sense? So if you start out with this form of Charles' law, flip it, okay, to get the form that's going to help you solve for it. So if you're trying to solve for temperature, and it starts out with you setting it up where temperature's the unknown is down here on the bottom, just flip it, okay? Just flip it. All right. Because you got to have your unknown. You got to have your unknown on the top of a fraction. You cannot have it on the bottom of a fraction and solve it directly. You can do a bunch of manipulation and solve it, but you've got to eventually get that unknown on the top of a fraction before you can actually solve for the value you need. Any questions so far? All righty then.
That was Charles' law.
This is Charles' law. Yeah, Mr. Eiffel, when he built the Eiffel Tower, at the first level where there's a, like an observation platform, he had these huge iron plates made, and he put the names of all the great French scientists on there and put them all the way around. So you go to Paris and you see those names up there. Well, those are the names of all the great French scientists.
I wonder
Charles,
why up there.
Laplace,
Golly. I wonder why my name was up there.
Le Chatelier.
Yeah, Le
Did they
Chatelier,
help
my
build
cousin.
Eiffel Tower?
Did they help build it? Absolutely not. But it was just put up there in honor of these great scientists.
Tom, if I was going to make Eiffel Tower, you'd be on mine.
Yeah, you are.
If Tanner was awake. I don't even know. Ask Tom, he knows everything.
It says if you have a cylinder and you don't, so don't worry about it.
Tom and Tanner are gonna fight. It's gonna be great. Tom, Tanner, and Misha should fight. Three-way cage battle.
Let's go.
Misha's is like a rabid zebra. I wouldn't mess with her. Give you rabies.
You couldn't find her. She'd be mysterious.
What you trying to say, Josh?
I'm in the fight now too.
Mr. Taylor, have you ever caught a limit shark at the beach?
No, but you know what you need to be doing? Writing. Use this wonderful invention right here, okay?
The hand?
I don't have one. But it's a pen. I
Oh.
only have pencils.
We'll use a pencil then. Yeah, in fact, I'd prefer you use a pencil.
Yeah, because then you can erase.
I'm using a pen.
Why
You're
did
using
you
a
write?
pen.
Actually, that's kind of like a marker.
Because you're not here.
Like a fine fist marker.
Yeah, what Tanner said.
Yes.
So the other equation was indirect. The other
This is direct. The other one is indirect or inverse.
Does that say 20 or 209?
270K. With a decimal place right there showing that 0 to be significant.
What song is that?
I'm not listening right now.
Oh, I thought you were whistling.
I'm not whistling. No.
Who's whistling? What do you say?
It was his voice.
George just can't whistle. They can only come up with cool words like synthetic and foolish. You should make more words.
What's the last part there?
Pressure is constant.
Pressure is constant. Does it have to have no friction in order for this to work?
Well, yeah, technically, because if you got any friction, it's going to resist changes in volume, and so you won't get a perfect result.
Okay.
Okay? Which is kind of the problem with trying to measure this behavior with the things that we have in the lab. Because if anything we have to hold a gas in is going to have some friction. It's really hard to get a really good result for this behavior. Okay, now he had a device, Charles had a device to do that with. But, huh?
What device?
He, let me try to think now. Seems to me his device contained mercury, and we're not going to use any mercury in here. Okay?
Yeah, that's a planet.
He's also a mythical figure.
It's a car. That's Pluto.
Oh, yeah.
I don't even know it.
Okay. All right, so let's use the same process we did before.
Alright.
List all your knowns and unknowns.
So the meters,
Find the equation that fits them. Insert your knowns. Solve for your unknown.
Yeah.
Mr. Taylor, do we always have to list them? Is that part of like,
Isn't that what I said a while ago? You always have to list them?
I didn't know.
I said it's not negotiable. You have to do this, yeah?
he said you have to do everything I do. That's something.
Yes, you always have to do it for me, okay? Because when we get to the more complex stuff,
I told you there's a fly, man. I told you it's got
there's
juice
something in here. It's a
I
fly or
told you.
something, right? Yeah.
I'll
Okay.
get it for you, Mr. Taylor.
All right. Hudson, from now on, leave your pets at home.
Come this way. I bet you won't.
All right. Solve the problem, please, Brian. Brian. Solve the problem, Brian.
Can I try to do it on my own before you do it?
Sure.
I gotta figure out. So you said the variable has to be on the top, right?
The variable we're solving for, in some part of this process, you've got to get the variable you're solving for on the top.
Okay.
Okay? But it's basic algebra. You can do it.
Yeah.
You can do it. Yeah.
You can do it.
Say what?
We just start the equation with like instead of BT, we just write it T at first so that we don't have to.
Are you saying, can you go ahead and write it like that?
Yeah.
Oh. Yeah, I probably wouldn't, give you a hard time about that.
What was
Because they mean the same thing. Technically, they're the same thing. Okay? I need you to know that this is the classical way it's written. Okay? But yeah, if you write it like that, it means the same thing. So that's fine. I'll just have to stand on my head to grade it.
Can you walk on your head?
I'm joking. Come on.
How can you walk on your head? Your
I
head
know.
doesn't have feet.
We called you a little boy. You're bigger than a little boy.
Hey Brian, can I have my calculator back?
Yeah, in a minute.
There's an L. Oh, I gotta write in a minute.
Hey, how about that?
Over one?
Huh?
I didn't do that one.
No?
Yep.
How are we doing so far?
Got it.
I don't know. I don't have my calculator.
Why don't you have your calculator?
Calculator for?
Brian's got it.
Do not.